Ignition sequence starts.
Good morning. You've got a good view here inside the International Space Station Flight Control Room at NASA's Johnson Space Center, where a team of specialists is always on duty, keeping an eye on space station systems and working with the Expedition 66 crew members as they conduct science research on orbit and take care of their home in space. Commander Anton Shkaplerov and his American, Russian, and German crewmates have been busy this week getting the newest crewmates settled in on orbit and down to the business of supporting experiment operations, while packing up a cargo ship that's due to depart this weekend.
Houston Station on Space to Ground.
Welcome to Space to Ground. I'm Leah Cheshire Mustachio. The space station has 7 inhabitants hard at work once again. On November 11, NASA astronauts Kayla Barron, Raja Chari, and Thomas Marshburn, and European Space Agency astronaut Matthias Maurer arrived at the International Space Station aboard NASA's SpaceX Crew 3 mission. The astronauts launched on Wednesday, November 10th, just 2 days after their counterparts returned home on the Crew 2 mission, and leading to the fastest turnaround in history between a landing and a launch. The crew will live and work aboard the orbiting laboratory for approximately 6 months. To keep up with their mission, follow the International Space Station on Twitter, Instagram, and Facebook. As soon as the Crew 3 cohort arrived, it was time to get down to business. One of the major areas of scientific research on the space station is on the astronauts' own bodies. Some of the first experiments they perform help determine their acclimation to the microgravity environment, testing functions like dexterous manipulation, effects on the central nervous system and depth perception, changes in bone and muscle mass due to the release of phosphates stored within, and how an astronaut's ability to visually interpret motion, orientation, and distance may be affected by the spaceflight environment. These studies help us better understand how to prepare for and mitigate issues on long-duration spaceflights, and also provide insight on how to improve similar conditions for people on Earth. After its arrival to the space station in August, Northrop Grumman's Cygnus is scheduled to depart on Saturday, November 20th. Cygnus arrived with over 8,000 pounds of supplies, scientific investigations, hardware, and other cargo on the company's 16th commercial resupply mission to the station over 3 months ago. Northrop Grumman named this spacecraft after former NASA astronaut Ellison Onizuka, the first Asian American astronaut. Flight controllers will command the Canadarm2 to detach Cygnus and the waste packed inside and release it for a destructive re-entry into the Earth's atmosphere. After release, Cygnus will deploy the Kentucky Re-entry Probe experiment, which will test an affordable thermal protection system to protect spacecraft and their contents during re-entry. Live coverage of the spacecraft's departure will begin at 10:45 a.m. Eastern Time. That's all for today on Space to Ground. We'll see you next week.
A new set of astronauts has kicked off its 6-month mission on the International Space Station. Give a listen as Raja Chari, Tom Marshburn, Kayla Barron, and Matthias Maurer describe their plans for science research and advancements in the commercial use of space, while contributing to preparations for humans to explore the moon in a few years.
I'm Kayla Barron, a mission specialist.
Hi, I'm ESA astronaut Matthias Maurer. I will be mission specialist.
My name is Tom Marshburn. I'm the pilot.
I'm Raja Chari, the commander of the NASA SpaceX Crew 3 mission to the International Space Station.
So the Crew 3 mission is on the NASA SpaceX commercial space vehicle to the International Space Station. We will be working on the International Space Station for around 6 months, doing lots of experiments, lots of science.
And Crew Dragon is one of our newest ways to get there. There have been Soyuzes that have flown to the International Space Station with crew. The Space Shuttle flew to the International Space Station, and now the Crew Dragon is taking human beings to the International Space Station. So we've partnered with SpaceX in the Commercial Crew Program. They design, build, and operate these vehicles that take us, transport us to the International Space Station so that we can contribute to the amazing work that we're doing up there.
Yeah, it's exciting to fly on a new spaceship for sure, and a new design of a spaceship. But I'm looking forward more to flying with three people that haven't flown in space before. This is a very unique crew. They are incredibly operationally savvy already. So what I try to do is, if there's any gaps in their knowledge of how they're going to feel, how they're going to operate, what is the zero gravity going to be like, how that might challenge our expectations for what we can get done. So you really feel like you've become a resident of space, a resident of zero-G, and you start to feel like you're getting an idea of how this works. Every day is a long series of problem solving. You got to figure out where to put your pencil, where to put your drink if you have it. So maybe 10,000 times a day you're solving little problems like this, and when that becomes fluid, then you really feel like you can be efficient and get a lot of work done. And there's a lot of work to get done on the space station right now.
We spend a lot of our time training in Dragon because that's a really dynamic phase of the mission, but it's just such a tiny fraction. The whole point is going to the space station and doing some incredible work up there. So our time on the space station is spent, one, keeping the space station healthy. It's been up there for 20 years. There's a lot of systems that need maintenance and upgrades and operators there to keep them working well, but we also do some incredible science. The space station is a national laboratory orbiting around the Earth, and it's a really, really unique environment.
Once we arrive on the International Space Station, we will run a lot of experiments. I'm a material science engineer, and so my focus will be lots of experiments in the material science domain, but also life sciences will be very important.
There's all kinds of research going on a daily basis that lead to just fundamental changes in the way we understand how our world works. I will definitely be the eyes, ears, hands, and the actuator for the experiments that help lead to the science, the discoveries that can push our species further, both beyond the planet and just understand and operate on our Earth even better.
One of the great legacies of the space station is not just going to be the science, but very importantly, the international cooperation. This is one of the first, certainly today's perhaps most prominent, international cooperation for exploration. It's not for survival, it's not for competition in the marketplace, it is for just exploration.
I think we're now about to enter a new era of human spaceflight. In the past, astronauts flew to the International Space Station to do purely science. Now the station will become more and more commercial. There are commercial experiments on one side, but there are also commercial astronauts who come up to run maybe their own science programs, but also to enjoy just being up in space, to experience space, and to convey this message, the fascination of space, to all the people on the ground.
The International Space Station's mission is to encourage commercialization of spaceflight and space research, and to serve as a science laboratory, to support future exploration into deep space, and to promote international cooperation. All of these goals come together when the station is used as a launch pad for a series of small satellites known as CubeSats.
Small satellites yield big discoveries. Presented by Science at NASA. Remember the old adage, big things come in small packages? NASA has updated it in the form of CubeSats. Imagine a real working satellite that's so small you can hold it in your hands. Just 4 inches or 10 centimeters across, these cubes can be expanded incrementally depending on their specific mission objectives. Originally developed in 1999 by Cal Poly San Luis Obispo and Stanford University for education purposes, NASA has since used them for new science missions and to test new electronics, sensors, and software that might be included on larger missions. Mike Seablum, Chief Technologist for NASA's Science Mission Directorate, says, "The ability to test new technology at a fraction of the cost of a larger satellite makes them invaluable. It really opens your eyes to many possibilities." Just as eye-opening is the way CubeSats are quickly unlocking new scientific data. For example, while conventional satellites have long observed clouds and have provided estimates of the liquid precipitation they hold, they have never observed the smaller ice particles that create enormous rain clouds. The CubeSat, known as IceCube, contained a new sub-millimeter wavelength radiometer that could make a space-based measurement of the small frozen crystals that make up ice clouds. After being deployed from the International Space Station in May 2017, IceCube created a global map of ice clouds around the planet. Someday, this technique may help improve long-range weather models and forecasts.
A long way from Earth, Marco A and B travel to Mars and are the only CubeSats so far to leave Earth's orbit.
When the InSight mission was launched in May of 2018, the Marco A and Marco B CubeSats also began their 7-month journey to Mars.
Now InSight has successfully landed on the Red Planet. One of Marco's roles was to help relay communications during InSight's landing process. Landing data was transmitted to the Mars Reconnaissance Orbiter, where its radio stored and forwarded results to Earth after a delay. Marco A and B acted as a bent pipe signal relay during this critical stage of the mission to allow communication from Mars to Earth to happen in almost real time.
According to Charles Norton, Special Advisor for Small Spacecraft Missions in NASA's Science Mission Directorate, another advantage of these compact cubes is they allow for very focused scientific inquiries to take place. The Miniature X-ray Solar Spectrometer CubeSat, or MINX for example, is a student project using a commercial laboratory detector in space. MINX measures the soft X-ray solar spectrum in the gap of energy coverage between two other missions, RESI and IRIS. This gap region in the solar spectrum is important in the excitation of the Earth's ionosphere and of particular interest for observations of solar flares and active regions. Or consider a discovery as monumental as the origin of the universe itself. One long-standing mystery for astrophysicists is where 1/3 of the baryonic or ordinary matter that existed during the early formation of the universe might be found today. Scientists suspect it lies in the very hot halos of gas that surround galaxies. HaloSat is a CubeSat that will examine X-rays from oxygen atoms surrounding our Milky Way to determine how much missing matter may lie in the halo of our galaxy. While small in size, CubeSats have potential to make big scientific and technological impacts on Earth, in our solar system, and deep into the universe. For more about other science missions, both big and small, visit science.nasa.gov.
One thing we've already learned about supporting human beings in space on long missions is that they have to exercise to fight off the negative effects of the weightless environment, and the International Space Station has been the proving ground for a number of systems to accomplish that goal. In this Speedy Time segment, astronaut Peggy Whitson gives us a rapid-fire display of exercises that can be done with just one piece of equipment, the Advanced Resistive Exercise Device.
Today we're going to talk about exercise in space. We have 3 different exercise devices here, and I'm going to talk about one of them. Of course, in zero gravity we can't lift weights, so we have what's called a resistive exercise device. But it's got a really important feature. In order to protect the experiments that are going on board that might be sensitive to vibrations from us lifting this resistance, it's got a vibration isolation system that's actually very cool. As you move on the machine, it isolates any vibrations that we would have away from the structure and protects the science that's going on. And so we have to work out about 2 hours every day in order to maintain our bone and muscle mass. And this is my favorite, the ARED, the resistive exercise device. Squat. Sumo squat. Heel raises. Deadlift. RDL. Bench. Military press. Tricep extensions. Sit-ups. Curls. Forearm extensions. But you know what the best part about doing exercise in space is? The view.
The structure of the International Space Station relies on a series of trusses that are engineered to withstand the different forces that the station can encounter in low Earth orbit. In this demonstration video, astronaut Ricky Arnold explains the significance of these resilient structures and the different forces they're up against in microgravity.
Hey there, I'm NASA astronaut Ricky Arnold. Welcome aboard the International Space Station. Today we're going to talk about the Space Station truss. The truss segment is just about 100 meters from side to side.
A truss is a segment or part of the whole integrated truss structure. The trusses are used to support the 16 solar array panels, which provide energy for us, and radiators which get rid of excess heat that builds up inside the space station. The design of the truss involves triangles and beams, which can be seen on Earth in structures like bridges. Why triangles? Well, this is because of their unique geometric properties, their methods of transferring loads, and their spatial openness. Triangles are more rigid than rectangular shapes because they have fewer joints. The larger number of joints in a shape, the more prone that shape is to being impacted by shear forces.
What I'd like to talk a little bit about today is some of the forces that can act upon the truss. Well, the first force I want to talk about is compression force. And compression force is just like it sounds, two things coming together. So if we apply a compression force to the truss, what do you think is going to happen? Well, let me go ahead and do it. And you can see right here where the truss would bend. What do you think the opposite force of compression is? Yeah, it's going to be pulling apart. We call that a tension force. And a tension force is what's going to help maybe even rigidize the truss segment, but it also could potentially pull it apart. I'm not going to pull apart this tape measure because we probably need it later for some work we have to do.
Now, if you look carefully, this next force I want to talk about
is basically kind of like a twisting force, and we call it torsion. And even when I just let go of the tape measure, you can see it will actually start to happen a little bit. You can start to see, because the center of mass is actually right here, where most of the tape measure is located, and when I let it go, the tape measure itself starts to twist just a little bit. Finally, the fourth force
that can act along a truss segment
is that can occur at a single point where two opposing forces work on a single point along the truss, just like they can upon the Earth's surface. Think about some earthquakes. You can have a plate that is, or along a fault line where one side of the fault line is moving upward or being forced upward while the other side is moving downward. And that force in one point in opposite directions is called a shear force. And we can also have that happen on the truss segment. Something like this.
One thing to think about, where do these forces come from?
One force, even though we're up here largely out of the Earth's atmosphere, we do still have drag with the Earth's atmosphere, which can impart loads on or impart a force on the truss segment. Another, I already hinted at earlier, is crew working inside. We're up here, we're exercising, we're moving really heavy pieces of equipment around. So we have an amazing engineering team on the ground, and we have specific disciplines their job is to monitor all the forces imparted upon the International Space Station. They keep track of all those various forces I talked about and where they could be coming from, the atmosphere, visiting vehicles, or even things that the crew are doing inside the space station, and to make sure that those forces aren't significant enough to cause any damage to this wonderful laboratory and living space we have up here in low Earth orbit. Thanks so much for joining me today. We'll see you next time. So long.
One key to a successful long space journey is the ability to provide fuel for your engines and oxygen for your humans. And the International Space Station has been home to many demonstrations of technologies designed to provide those critical supplies. Previously, NASA's Exploration and In-Space Services Projects Division at the Goddard Space Flight Center showed us the first 2 versions of the robotic refueling mission payloads. In this Tech on Deck, they focus on RRM-3.
For generations, Mars has beckoned. Now, the red planet is within our reach. But how do we get there? The key is in the details, and in the technology. First and foremost, you need fuel. This is not only true for getting to Mars, but for any form of deep space exploration. Being able to replenish fuel on a long-duration journey means massive amounts aren't needed up front, freeing up space for other important things. Enter Robotic Refueling Mission 3, or RRM-3 for short. This demonstration launched to the International Space Station in December of 2018 and has helped us develop tools and techniques needed to replenish cryogenic fluid in space. Transferring cryogenic fluids has never been done before in space. These super cold fluids can be used as propellants, coolants, or for life support systems. Being able to replenish these fluids that run out, otherwise known as consumables, is an important part of the sustainable exploration roadmap. Not just for Mars, but for NASA's Artemis program, which will land the first woman and the next man on the moon. Since refueling cryogenic fluids in space has never been done before, RRM-3 tested the technologies and techniques needed to make that possible. First, we sent the RRM-3 payload and its 3 main tools to Space Station, where astronauts assembled the parts.
When I was living aboard the International Space Station in the spring of 2019, I was fortunate enough to take part in the very small part in the Robotic Refueling Mission 3. And my job was to unload the components of the actual RRM-3 from one of our visiting vehicles, and we take it into our Japanese experimental module, the GEM, where we have an airlock. And right inside of the airlock, we unpacked all of the boxes, much like you would a piece of furniture that you had to assemble yourself at home. So unpacked all of the pieces, we did a checkout, we worked with the ground, we got everything assembled, and then we placed it into the Japanese airlock. And from there, we were able to put it outside of the International Space Station. So my involvement in RRM-3 was the physical final assembly of the actual components.
RRM-3 was delivered to the space station by a SpaceX Dragon on the company's 16th Commercial Resupply Services mission and installed on the outside of station by the Canadian robot Dexter. Dexter then picked up the tools from the JEM airlock and installed them onto the RRM-3 payload. The ground operations team was now ready to begin operating the 3 tools to test how they would work in space. For the first set of operations, conducted in August 2019, Dexter used one of the RRM-3 tools to prepare the RRM-3 module's interface for transferring cryogenic fuel. The second set of operations was then conducted in October 2020. For these, Dexter used one of the remaining 2 tools to insert an 11-foot-long hose in an open port and the other snake-like camera inspection tools simultaneously to verify the hose's position in the inside of RRM-3's tubing. This marked the first time that Dexter had tools in both arms working the same tasks simultaneously. The RRM-3 demonstration added experience and information to NASA's knowledge base on the storage and transferring cryogenic fluids in space. It is currently still on station, where it will conduct one final set of operations in mid-2022. For getting to the Moon, Mars, and beyond, cryogenic fluids will be used as propellants and to maintain life support systems for astronauts. The Mars atmosphere is made up of carbon dioxide, which could be converted to liquid oxygen, a type of cryogenic fluid that can be used both as propellant and for breathing. Astronauts may be able to fuel rockets or replenish their oxygen supplies using compounds found in the Martian atmosphere. A tool on the Mars Perseverance rover called Mars Oxygen In Situ Resource Utilization Experiment, or MOXIE, is set to demonstrate the first ever conversion of Martian carbon dioxide to oxygen, which is another important piece of the puzzle. In order to make a sustained human presence in space a reality, humans and robots will have to work together using technologies like those developed by RM3 and MOXIE.
A lot of people ask about, whose job is exploring outer space? Is it robots or is it humans? And I believe that it requires teamwork between robots and humans, and that our exploration is not complete or even possible without both. So robots can go farther, they're less expensive, and they can go for longer periods of time. They don't require as much maintenance. You don't have to feed and care for a robot, much like you do if you send me back to space. So like the Mars rovers, the Galileo that explored Jupiter and its moons, the Hubble and the soon-to-be James Webb Space Telescope, they are doing missions in locations that humans, to this point, don't have the capability to go. There's also something very important about humans wanting to know what it's like to be there. It's not enough for humans to take a picture of Mount Everest or Antarctica and say, oh, okay, that's what it looks like. The human condition is we are born to explore. We're born to say, what if? What's just beyond what we know? And what is it like to be there? And so the human side of space exploration, first of all, it's orders of magnitude closer to Earth. We have not been able to send humans nearly as far as we've been able to send robotic probes. But they're two very different missions, and they serve a different type of curiosity.
Mars and deep space are calling human explorers, and RM3 is a step toward helping NASA answer that call. Though it sounds complex, the idea is simple. Having the ability to refuel will allow NASA to embark on longer journeys to explore the depths of our solar system.
Want another look at any one of the stories we showed you today? Well, you can find them all on YouTube and Facebook. They're right at those addresses, right there on the screen. They're rubbing shoulders with lots of other great features on a whole variety of NASA topics, so be sure to look around. Now, if you're looking for good conversation about human spaceflight, check out Houston, We Have a Podcast, our weekly show about all aspects of human spaceflight and NASA's missions of exploration. Today, Gary Jordan has a great conversation previewing the science plan for Expedition 66 in a talk with Mandy Cady, the Increment Research Lead for Expedition 66. Go to nasa.gov/podcast for this week's episode and all the previous episodes and the full library of all NASA podcasts, which are also on Apple Podcasts, Google Podcasts, and SoundCloud.